Ei. Ei, ei. Testando. Ó, ficou bom, hein? Pronto. Today I'll be recording a video. I want to record a video about topology, and I have a script. I have a script right here, and I'll be following it, and I'll be following along modeling some things for my spaceship on Blender, right? So okay, I pulled up the Blender file, and we have here a project that I've been working on for the last maybe 3 weeks, 3 weeks or more. So adjusting my monitors here. Okay. And I'll be talking about topology, and I have this piece here, which has somewhat okay topology, right? But it's not very great. And overall, I have not aimed for topology in this particular design, right? So I've been just modeling and seeing how it goes. But in this video, I wanted to start from scratch with a new part, or to maybe start with a simple part and start recording it with that. Okay, so let's pull up the script here. Now here I have the script, and in the start of the script I will be talking about when you try to subsurf, right? When you try to subdivide your model and suddenly you have a pretty big mess. So let's start. I think I'll start a new scene. Not 100% sure on that, but let's see. I think I might start a new file. File, general, save. Okay. We have, first off, let's delete the main cube, the camera and the light. Now let's add a cylinder. Cylinders are particularly good for topology demonstrations because they have bad topology by nature, right? So they are created with bad topology, and it's our job to fix to fix the bad topology, right? So let's share the screen. Okay, it's badly placed. Let's place. All right. So cylinders have particularly bad topology, and when we try to apply the subsurf modifier to the cylinders, it doesn't behave. Oh, sorry. It doesn't behave as well as we expected. It just doesn't work, and no matter how we subdivide it, I don't care if I shade it auto smooth or shade it smooth. It looks like kind of an onion, right? It doesn't look great. And that's the thing. The cylinder, in general, has bad topology. Right? And what I mean by bad topology is it has no edge flow, no good edge flow, and it uses polygons with much more than just 4 sides. Like for example, this one and this one are particularly bad polygons because they have like 32 sides, right? So let's demonstrate this, and I'll start recording right now. I think I wanted to have like a clack so I can start and stop the recording, like a sign, a signal, right? But no, let's just leave with it. So let's start. This looks wrong. It doesn't do. Okay. Three, two, one. If you're new to 3D modeling, you certainly try to If you're new to 3D modeling, you certainly try to apply a subsurf modifier to If you're new to 3D If you're new to 3D modeling, you certainly try to apply a subsurf modifier to a specific mesh, and it came out like this. Okay, so let's do the B-roll. B-roll time. Take the cylinder and apply the subdivision surface modifier. Boom. It turned out like this. Three, two, one. In today's video, today's video, I'll try to explain why that happens and how you could try to fix it by learning basic concepts about topology. In today's video, I'll explain why that happens and how you could try to fix it by learning basic concepts about topology. Stay tuned. Okay, now we play an intro. Intros played. Okay. Now let's pull out a triangle. Triangle. I don't think there's no such thing, right? So, quad. No. Delete vertice and interface. Now let's duplicate it. This should be a quad. This one should be a quad. I'll just add one here and move it. Shift Z here. There's a quad. And now I want a poly, an n gone. Let's just dissolve this edge. I don't want to dissolve the vertices. Control E to subdivide, okay? And then we have a quad. And I'll do, no, not a quad. We have an n gone. And I'll do once more. Now I'll apply a little bit of a color, just so it's not that bland. And I'll do a matte cap, maybe. I don't know. I don't know how to do that either. Here, matte cap. Um, and this random, it's kind of shitty because the random chose um, okay. I just want to show viewport display wireframe also. Edges, I don't. I think it's working, but the wireframe is too. Oh, okay. And the wires are too like small, too 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 tiny, but okay. So here we have it. To start our journey through topology, we first need to learn what are triangles? It's quite a obvious. It's a pretty obvious concept if you model for a while. It's a pretty obvious concept if you model for a little bit. To start our journey through topology, we first need to learn what are triangles. To start our sorry, 1, 2, 3, go. To start our journey to topology, we first need to learn what are triangles. It's quite a sorry. It's a pretty obvious concept if you model for a little bit. It's a pretty obvious concept. If you model for a little bit, you may know what they are. Oh no, this is bad. If you model for a little bit, you may know what they are. But I'll just show it for those who don't know. Triangles are faces composed of 3 vertices. Tries are polygons composed of 3 vertices. Sorry. Triangles are sorry. Triangles are faces, not faces, I'll say polygons. Again. Triangles are polygons composed of 3 vertices and 3 edges. This shapes the underlying shape for everything you model. Everything on your mesh, it's triangulated at some time, right? Even quads, which are squares or rectangles, are divided into quads later on. For our next shape, we have the quads. Quads are pretty basic also, and they are the desired shape for modeling with good topology based on edge flow. They are the most used and what you aim to create. But as I said before, under the hood, they are interpreted as 2 triangles connected. Maninho, vambora! The quads allow you to do such things as edge loops and edge flows, and they are very, very important objects for topology. Let's demonstrate the edge loops. Let's demonstrate an edge loop, a pretty basic edge loop on one single face. Let's go to editing. Let's go to editing mode and press Ctrl R. I'll enable the references, and I don't know input and off. Reports. I don't know if it's an add-on. It's a key visualizer which displays the keys. Key strokes. Let's see. Show key strokes. Blender. Screencast keys. Oh, you have to download it. I'll download this add-on screencast keys to, let's see. No, there's no screencast keys. It isn't It isn't offered anymore. Let's see, what version of Blender do I have? I don't know, I think it's 3.5. I don't know. No. This one. Screenshot, show status bar, and export displays. Oh, here, 3.5. Okay, so we have Blender 3.5. Let's download. Screencast keys.zip. And I don't know, where do I throw it? Where do I... How to install? Let's just unpack it for now. Extract everything here. Okay. Now I'll try to paste it somewhere, I don't know. Installation process a little bit confusing. Let's see. Blender installation 2. Oh man, but I downloaded this. Let's see. Let's see. Sorry, I'm trying to install. Let's see, help, edit, preferences, maybe official install. Oh, maybe here. Be here. Screencast keys, screencast keys. Maybe? I don't know. Refresh. I don't know. Yeah, I know. I know you're not seeing my screen, Gabriel. Bem-vindo, maninho! Mas é porque eu tô fazendo umas instalações aqui e eu realmente não quero mostrar, não. É de propósito. Ah, okay. You have to click preferences, install, and you have to choose the downloads. You have to choose the zip file, not the folder one, the zip one. So this one, install. Okay, here we go. It didn't work. Traceback file C. Init. User register class preferences display all text properties already registered as a subclass. I don't know what's happening. I just tried to install. Enable add-on. I'll just paste this. Location of an add-on folder depends on your operating system. Folder doesn't make it in advance. It's app data. Here, here. Users. App data. Roaming. Blender Foundation, Blender 3.5, and folder scripts, add-ons, screencast keys, and copy add-on sources into add-on folder. Just remove it, remove, and it goes away. Let's download the manual, install one, and try it. I'm sure I have Blender. It's not Blender 3.5. It's this. Okay, so it isn't supported. Oh, this one is 3.10. So let's try and download it. 3.11. Let's try. Download screencast keys. It's the 2.1. Screencast keys to install add-on. Let's try. One more time. No, it didn't work. Fuck. Oh god. Okay, let's try to install it. Let's try to install it. 3.10. This one, 3.10. I'll install the source code. And let's see. Download screencast keys 3.10. Screencast keys 3.10. It's not this source code. Source. I think it's this. All right. This doesn't work. Oh my god. Missing one required positional. Man. Oh my god. I'll try to restart this. Let's save this. Save this as. I'll close it and open it again. Oh, it did work right now. Okay. enable on startup. Let's see the docs to see if we get this working. Okay. Now, now where it is? I don't know. I don't know where it is. Show last operator. Update. Update. Okay. Not aliases. Space 3D view. Okay. Overlay. I don't know what's happening. I really don't. It isn't working. Oh, here it is. Let's enable it. Let's see. Oh, now it does work. Okay. But it is at this side and I don't really like it. Okay. Now it is enabled here. Oh, right. Region, area. Okay. Now we can use here. Vision cursor. Oh, this is bad. Window. No. Region. Region. Okay. So 130 and like 0. I want not a lot of margin. Line thickness. I can have 1. Model size. Okay, that's a little bit bigger. Like 60 is good. And line thickness can be a little bit bigger, I think. The font, a little bit small. That's 20. Nice. Okay. Now it's just a little too bit to the right. Now, hello and welcome. I'm trying to set up this thing to work. It works a little bit, but it's not um, it's not fitting very well to the screen. They're a little bit grayer too. No, this is bad. This just looks bad. Okay. Let's see. That's right. Okay. I hides. No, I don't want this. I want the region. Oh, this is good. This is good. This is good. All right. Now with our setup, everything's all right. And we can continue the recording, which I was on somewhere. Okay. I was trying to demonstrate the loop cut or the edge loop cut, which is for quads. We can go into edit mode and press Ctrl R, and then we have this like yellow line across the face, right? So with this yellow line we can create an edge loop. An edge loop, it's in this model is just a new edge, but in a more complex model it would create a group of edges which would follow the current edge flow of the model. But I need to explain. I need to explain better what is edge flow, right? But we'll do that later, right? Okay, now we have the n-gons. N-gons are polygons composed of more than 4 edges and vertices. In this case, I have a 6 edge n-gon, 6 vertex n-gon. And these are pretty bad shapes. They are usually avoided by modelers. If you're trying to model something in the subsurf way or the subdivision surface way, they can be allowed on flat surfaces, or when you are trying to model using booleans, they are somewhat allowed. And if your model doesn't need to deform, because topology is very, very important. If your model is required to deform, animate, bend, all right? So these are usually avoided for this pretty big reason. I'll try to demonstrate by trying to create an edge loop here, and you see that none are created. No edge loop is possible across this n-gon because the software just doesn't know how to do it, right? It does know how to do edge loops with quads, but it doesn't do n-gons. And this is a pretty big deal for the subdivision surface workflow, which is a way of doing things using the subsurf modifier, which is a pretty big deal. Now let's talk a little bit about edge loop and edge flow, right? Edge flow is a modeling technique that makes edges and vertices flow the surfaces of a model. Let's try to demonstrate this in a better model, right? So let's, for instance, let's pull up a model from the internet. This here is a pretty good example from the website. Oh, sorry. This here is a good example from the website Blender Artist. Here you can easily see that the left model has better edge flow than the right model, right? The right model, it's too stiff, it's too square because the edges and the polygons doesn't the polygons and the edges doesn't flow with the surface deformities, right? We can try to replicate this. Let's try to let's say I extrude this here and I just do like this, right? Okay. Now this set of objects, let's just hide this. This set of faces have pretty bad edge flow because let's say I'm trying to build an arc, right? And I wanted to, oh, this is bad. Scale, set 0. And okay, let's say I was trying to create an arc, right? I wanted to do an arc from here to here. This isn't the way to do it, obviously, but this is just a simple example. And it doesn't have good edge flow. It means that these edges are not really aligned with the flow of the model. So if we try to do let's say this model is a little bit bad, right? Let's extrude it like here. You see, it's not very pleasing, right? And if you try to subdivide it, I know that there's a hotkey for that, and I think the hotkey is let's just practice the hotkey. This is wrong. I think the hotkey is Control-1. Yes, Control-1, and it's the hotkey for subdivision surface, right? It looks okay, but it's not what we wanted because the shape isn't holding volume. And for that, we have to thank for the bad edge flow, right? In this example, you can see that this kind of modifier tries to do edge flow. So these edges are following the surface of the mesh, right? This is thanks to the Catmull-Clark algorithm. The Catmull-Clark tries to smooth everything and create edge flow, right? So it's somewhat okay edge flow, not very good. The simple algorithm just divides the edges without doing any edge flow and any smoothing, right? So Catmull Clark is what we want like 90% of the time, right? Edge flow edge flow can be explained in a simple way, in a simple analogy. Let's just imagine that you have a grid of points, a grid of points and edges, and you want to wrap this grid in your mesh. Edge flow aims to do this in the smoothest way possible, in the prettiest way possible, right? So this isn't very good because because my surface is going like this, right? But this edge loop is going like this. The angle doesn't match with the angle that I'm trying to convey in my surface. A good way to fix this would be to just try to rotate this and kind of match the angle that I'm going for. This could be a start. This does have a little bit of a better edge flow. Right, it's not looking so bad right now, right? Oh, I'm doing this the wrong way because I'm doing this without this enabled. So I have to have all the mesh doing this. Now this is working, right? So this would be a first way to fix this edge flow problem. Now we have like a banana shape, but it has better edge flow than the other one, right? So this is good. If you subdivide it even more, you'll see that grid thing that I'm talking. Let's see. I want to. It's optimal display. Okay. This is the grid thing that I was talking about. You see how this modifier tries to wrap a grid around the model in the prettiest way possible, like trying to keep the face density as good as it can. So this is what it does, and this is good. It isn't 100% because you see here I have more faces than in the rest of the model. Optimally, you aim for square-ish faces, right? So this is a thing. This workflow do as many benefits such. This workflow has many benefits, such the control that you have for the control that you have of your model. This workflow has many benefits. This workflow has many benefits, such as the control that you have of your mesh, and the control of the density of detail that you can have on, and also you have better normals interpretation by the software, right? Now, edge loops. Edge loops are a consequence of the edge flow workflow. Loops, in a simple way, loops are a way to connect all the edges and vertices in a loop, right? In a closed loop on your model. So you have to imagine a line crossing, not a line, it can be an arc, but a series of lines or connections crossing your model and trying to cross all of the polygons of your model in one way or another, and looping back and being connected, right? So for an example, you can try to apply an edge loop here in this model. Okay, let's just hide this modifier for now. And if you try to apply an edge loop in this model, we will have these two behaviors. We will have these two behaviors. One of them is it creates a really simple edge loop. This is an edge loop, right? It loops back, it cuts your geometry, and it's closed, right? It is not an open loop. You don't want open loops, basically. I mean, you can have open loops if your geometry is open, actually, right? This is allowed, right? And we have edge loops in the other direction too, and this is good. We can create more edge loops in other directions. So this is a signal of good edge flow workflow, right? So we can create many edge loops, and this is actually what empowers this method to create detail, right? You can refine detail on areas that you want without compromising the overall topology, right? Okay, let's do an example right here. I'll hide this too, and I'll make just a plane, and I want to let's add some color. I'll do a green plane right now. Okay, so let's pick the knife tool with K, and we will create sort of a funky little shape here. I just want to create a really bad shape to try and fix it with edge flow, with the edge flow workflow in mind, right? So let's see. Okay, now let's delete this face. Delete this face and delete this one. Now this is a pretty big n-gon, right? But let's say that we want to do a shape like this, right? It's a simple shape. I can close this one here, and it's gone wrong. Why though? It's already closed off. Okay, we don't need to worry about that. But let's say that we wanted a model just like this, but we wanted to apply a subsurf modifier to smooth the edges, right? To do like a good bevel and to add detail to this. So let's just apply it with Control 1. And here it is. Bad topology all over the place, right? Okay, let's just hide this for a little bit. And let's go into edit mode and try to apply an edge loop. No way, no way. We are not able to apply an edge loop, at least not able to apply an edge loop cutting the big face that we have here, right? These faces we can, because they are all quads. If you notice, all of the sideways faces are quads, so they are okay. They don't have the prettiest edge flow, but they are fine, right? Okay, now let's try and fix that. The first way to fix this is to try to think about the edge flow, right? So we might want to, this is a little bit free. You don't have to follow the step by step, but let's see. We want to follow the edge flow. So we want to follow what edges are present in the model. So we can pick a knife and cut it here. When we cut it here, we create a face and we create a quad. This is a pretty big deal because we are trying to eliminate the n-gon, the big n-gon here, and creating quads is a good way to do that. So we can do, let's try to do, let's try to make the knife go through the thing. See, cut through. I think that's it. Okay, now we cut through this model and we have quads all over the place here, up here, right? Okay, now let's think about this bottom part. Again, we can use this and try to follow the edge shape. Let's do C. Oh. Again, let's knife, this, C, and that. Okay, good. Now we have this pretty big n-gon here, but we have another place that we can do the same thing here and here. I think that was it. Okay, now we have this pretty big face with 1, 2, 3, 4, 5, 6, 7 vertices, right? With 7 vertices, we can try to do, like, we can try to cut it here. Again, let's use a knife. The knife is your friend here. And here. Oh my God. Sorry. This and this, enter. Okay. Now this is somewhat of a problem here because we have a polygon with 1, 2, 3, 4, 5 points, 5 vertices, right? And we want to divide it. We can do an edge loop here. We can go here, cut here, here, and here. Again, let's do here, 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 and here. With C to cut through and enter. It didn't work. The cut through didn't work. Let's undo. Let's try again. Here, 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 and here. Okay. Now this model, I forgot this one. This is a pretty small detail. Let's say that we wanted we are in a blocking out stage of the model. So this small detail should be just deleted, right? So we can dissolve edges. Okay. Now everything is quads. Everything is Now everything is quads. Now everything goes somewhat with the flow of this model. And again, and now let's try to apply the subdivision surface modifier once again. Look at that. This is way better looking than the other design that we had. And now we have the power of edge loops. We can do Ctrl R and cut the shape to refine the detail that we had, because we have good edge flow, right? I'm sorry, not here. So R here. Now, let's say I wanted to do something like this, right? It's smooth, and this is not bad at all. We don't have any apparent normals problem, and it's a pretty wonky shape, a pretty bizarre looking shape, right? So this is what good topology does to your workflow. Okay, this concludes for edge flow and okay, this concludes for edge flow and edge loops. Now I'll try. Now I'll talk a lot. Sorry. Now I'll talk. I can't say this word. Now I'll talk. Sorry. Now I'll be talking about poles. There are two main types of poles. E poles, E for extrude poles, and N poles, which are nose poles, right? Let's add a plane just to start, and let's color it. Let's do, I'm feeling kind of a lilac or purple, I don't know. Okay. I'm sorry, Guilherme, I'm reading from a script here. The last part wasn't really scripted, but I have like bullet points that I am going through because I'm recording a video. This live stream will eventually become an. I think I'll try to do a a good edit and to do a video about it, right? So I'm sorry if I'm repeating some stuff, but okay, let's try again. Poles. There are two main types of poles, E poles and N poles. Extrude poles, or E poles as they are called, are poles created when extruding faces. Let's show an example here. I don't know if you heard, but my cat just meowed very, very loudly here. Thank you, thank you. Thank you for your support. Hey, come here. Mika. Look who came. Mika. Let's show him. Ah, here. Look how good, how cute he is. I'm recording a video. Oh, now, now his tail is just on the camera. It's all right. It's all right. No, don't hit the camera. No, no, no. Oh my God. Now you're here too. Here. I love cats, man. Cats are awesome. Let's try to continue. So I was talking about extrude poles. Let's first explain what is a pole, right? A pole is a vertex that connects three or more polygons, right? Three or more. In this case, three or more quads. In this example, we have the two kinds of poles that we have. we have and a connection of four polygons or four quads isn't called anything, because it's the most common way to connect is to connect four, right? If you extrude here, sorry, did something wrong. If you extrude here on X, this is a vertex that connects four quads. It's the simplest way to connect, right? And it's flat. But this vertex connects five quads, and this vertex connects three quads. This vertex is what is called an end pole. It's a nose pole because it's on the base of the node. If you're modeling like a character, the base of the nose will have this kind of poles. We have two poles like this. And the extrude poles are poles that are extruded, right? The edge, the like corners of a cube are made of extrude poles, of E poles, right? So these are poles that connect three faces, right? Let's see. Let's record that. Let's record that now. Okay. I think I said that already, but I'll say it again just in case. Okay. Extrude poles, or E-poles as they are called, are poles created when extruding faces. For example, the corners of a cube are all extrude poles. They are composed of three faces connected by a single vertex. Now my cat again. Sorry. You're too cute. Oh my god. The E-poles can Oh my god. Calma, filho, vem cá. Você quer ficar aqui no colinho, neném? Ai, ai. I can't. He's not letting me record today. Okay, he's gone. I think. He's not gone. He's here, but it's not in the way. Oh my god. Okay. Okay, let's start again. He's gonna pass through here again. Look, the tail. The tail! I think that you're too cute. Oh my god. No! Don't! Lindo. Okay. Now I think he's gone. Okay. Okay, let's see. Let's see where we left off after this short intermission. Okay. E-poles are always composed of three faces, three quads, and they converge in a single vertex, forming, as we have seen, the corners of a cube, right? But they're not exclusively sorry, but they do not appear exclusively on corners of the surfaces. They can appear on the planar surfaces, right? So we can have here, let's demonstrate, we can have, sorry, we can extrude this again, and let's try to make an e-pole here, right? We can have an e-pole by connecting 3 quads in this mesh. The quads don't have to be square, meaning that they don't have to have right angles all the time, right? So we can do like this. Like, let's try to inset these faces, and I want to inset these faces, and I want to clamp on the boundary. Okay. Now look at this. This this is an e-pole, right? Because we have 1, 2, 3 quads connected by a single vertex. Let's try to organize this mesh a little bit better by doing this and this. G, X, and I'll try to I'll just use a knife to cut this thing here. Sorry, what happened? I just wanted to cut it here and here. X, Y, okay. Y, okay. And now we want to dissolve this, this, and this. Like to dissolve these edges, right? This is now a little bit bad. This is not very good topology here, but I mean, I'm interested just in these faces. I will separate them. I'll just clone and separate selection, and then I'll hide this. Okay, let's drag this here. Solve this. So vertex. G, Y. Okay, now this is a little bit better. This is a representation of an e-pole, right? Which is 3 quads connected in a single vertex. Sorry. This has a very interesting behavior when you try to create edge loops and edge cuts and loop cuts, right? So let's try to extrude this a little bit on the Y, I think, and extrude this on the Y as well. No, sorry, on the X. I'm just oh, no. This isn't connected, so let's merge, center, distance. Okay, somehow it wasn't connected, but okay, now it is. Let's extrude this on the Y direction too, and extrude this on the X direction, right? Now, this mesh behaves a little bit differently than the other mesh that we work with, in the sense that it doesn't have straight loop cuts, right? It won't have straight loop cuts because the end pole causes the cuts to curve, right? Any kind of pole except the regular one with four four polygons, that doesn't matter. But an end pole and an E pole will cause the loop cuts to curve around the surface, right? So if we try to do a loop cut here around this E pole, you see that the cuts curve a little bit about the surface, right? So again, this other one, it curves in this other way, a different way, right? It crosses in a 90-degree angle, right? And the other one crosses in this way. And you see that you can see that every one of those three cuts, which were this one, and this one, which were the three cuts that we did, they all cross each other, which is a feature of the E pole. The E pole causes the loop cuts to cross each other. So I'll read it now. I'll do the part right now. A special feature of the E pole is that it causes the loop cuts to cross each other, like this example that we showed. Like this example here. Like this cut, like this example in the screen. This cut, and this cut were all made around this pole, and they all cross each other, right? Now let's make an example of oh, this is high. Let's delete this and let's try to unhide some of, okay, this one. Now let's try to make an example of the 5 corner loop cut, which is this one, right? If you can try to imagine just a little bit of sidetrack here, we can try to imagine the loop cuts going through this corner, right? You can do a loop cut here, okay? Like think of this corner. We can do a loop cut going here and a loop cut going here. And this corner is surrounded by loop cuts that all cross each other. These 3 loop cuts all crosses each other, right? So this is an easier way, kind of easier way to think about poles, right? So on the other hand, N poles are poles composed of 5 intersecting quads in a single vertex. N poles are called N poles because they appear. N poles are called nose poles because they appear on the base of the nose when you are trying to sculpt a character. Now let's try to do an N pole here in this mesh. I'll just delete this because this is just the other kind of pole. Delete vertices. And let's extrude on the x-axis 2 times. Extrude again. It's not straight. G. Oh, it was straight, I think. Okay. Now I have to think a little bit about it, because the E poles are easier to think about in a surface, but the end poles a little bit harder. We can just do like this, right? We have this here. This is a we are aiming to replicate this pole on a surface, so we can just do like this. We can move it here, and we move this down here. Let's just delete these ones. Delete vertices. And let's redo faces. This looks bad. This looks very bad. But once we start moving things about, let's see, and bold, and bold. Okay. I'm trying to look at references of endpoles. Sorry for the sudden silence. Okay, here is a good example. And it's a pretty obvious one. Also, let's delete this and add a polygon. I think we have this or not. Let's add plain circle. Yes, circle. Okay, and we want a circle with no, not an empty. I don't want to add an empty. It's a circle, but it's a mesh circle with five vertices, right? Let's tab into it. Let's make a face and let's subdivide it. I think this does it. Not 100% sure on that. Control Z, I want to subdivide the face. Control E, subdivide. No, isn't working. It's subdivided like the edges, right? Let's okay. Here. 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 And join here. Okay. Now this is all quads. For as bizarre as it looks, it is all quads. And this is an and pole. I think looking in another source, I think I mixed up the names of them. I didn't mix up what they do, but I mixed up their names. This is actually an e-pole because it happens at the base of the thing that you extrude. And the end pole is the tip of the nose. The tip of the nose is an end pole. I'll try to record everything I said before again afterwards, not now. But this is an e-pole. I'll say the right name for now on. And this is accepted. It has acceptable topology, right? Because you can pass loop cuts through it, right? You can pass loop cuts all around this this e-pole, right? And a little bit of a difference between the e-pole and the n-pole is that the loop cuts that you pass through here, let's do, I'm feeling yellowish here, okay. The loop cuts that we pass through here will like kind of diverge from each other, right? So they will diverge from each other. They'll eventually cross each other, but they'll have a divergent behavior, not a convergent. I don't know if this word exists, but they will not converge around a single point, right? They'll try to diverge. Sorry. Let's enable the wireframe here. Wireframe, okay. And I'll add another circle, and let's try to do this in a better way, so then I can show it a little bit later when I have to re-record this. Here I'll try to do both of them with these easy shapes, so that it's a little bit easier, right? So I have to face, and I have to subdivide. Okay, now that's wrong. I'll have to do a knife cut here to here and here and here to here. Oh no, here to here. This looks like a triforce. Doesn't look like a triforce right now, but it did. These old edges. Now this is an end pole. Fixing my mistake. This is an end pole, and in this end pole you'll see that the edge loops like converge around the pole, right? So let's add a new material here. New material. I'll do the old Boa noite, boa noite. Bem-vindo aí, cara. Hoje eu tô gravando um vídeo sobre topologia, pela dica que você me deu aí de terça-feira. Eu tô gravando em inglês. Eu tô trocando ideia com o pessoal em inglês também, mas acho que só tem brasileiro aí na live. Mas eu vou gravar em inglês e eu vou tentar traduzir ele também. Se não der muito trabalho, eu vou tentar regravar ele algum outro dia com o mesmo material, mas tentar traduzir o que eu vou falando. Mas o primeiro que eu vou lançar vai ser em inglês. Bom, this is what I had to talk about poles, right? So let's try to read my lines here. um, I'll hide this one. Let's just report display. Oh. Okay, I'll hide this one. I'll drag this one here. Now, I'll re-record my lines for this design, right? Okay, let's start. On the other hand, on the other hand, E poles are composed of 5 quads are composed. On the other hand, E poles are composed of 5 quads intersecting in a single vertex, like this design shown here. This inside shape is an N pole because it has 1, 2, 3, 4, 5 quads intersecting in a single vertex in the middle here. We have already applied some loop cuts here, and a behavior that's common for N poles, for E poles, a behavior that's common for E poles is that they diverge the loop cuts. The loop cuts don't cross converging into the pole. They diverge the loop cuts, right? So as you can see, the loop cuts, I'll select the loop cuts here, right? And so they go away from the poles, right? Bringing up this shape again. Oh, not this one, not this one, not this one. I think I deleted the shape. Oh, fuck. Okay. I've shown it on the surface and on the corners, right? Now with this basic understanding about poles, let's talk about with this basic understanding about poles, let's now talk about reductions. Okay, so let's talk about reductions. Let's hide this, and I'll add again a plane. And reduction is it's a good topic. It's a great topic even. Reduction. Okay. Why? Okay, let's say resolve. I'll add a new material. I'll add blue material. Okay, didn't like blue material on this one. Okay, let's say I have these two meshes that I have to connect. You can encounter these kind of situations in the mesh that you're working with. You have a mesh that needs to connect a cut with 3 edges to a cut with 2 edges, right? And you could do this the ugly way by doing this kind of thing. But this, once again, has bad topology, right? This has bad topology for one single reason, and it is for this triangle right here. It isn't a quad, and this is a pretty big problem. Bye, Guilherme. Good evening to you, and see you again. Maybe tomorrow, I don't know. Have a good night. In this right here, it's bad topology because of this triangle right here, right? So this reduction is what is known as a 3-to-2 reduction. It's a 3 vertex to a 2, sorry, it's a 3 face edge loop to a 2 edge loop to a 2 face edge loop on this upper side here. And this can be done like this, but this triangle here will cause bad topology, and it can cause bad normals, right? It can cause your software to misinterpret this surface and to put bad normals if you subdivide it, right? There's a simple way that this can be transformed into a good topology workflow, which is by doing an and pole here, right? We just did it, right? We just did it an and pole, and let's just try to do it again. Let's just cut it here, here. Sorry, not this way. This way, here, at the center, and down below. Let's set enter, and this. This, and this. There's one missing, and this is this one. And this one is a 3-to-1, sorry, is a 3-to-2 reduction, which is very used, and it uses one and pole here to do the reduction. I need to just cut this here. Sorry, this one was missing. Okay. Oh no, this is now a 4-to-1 reduction. This doesn't work. Que foi? Que foi? Vem cá, vem cá, vem cá. Vem cá, vem cá. Okay. Now this reduction is it's a little bit bad because we have this, which is a triangle, right? So we have to resolve this triangle, and we can do that by dissolving this edge. And now we have 1, 2, 3, 4, 5 sides, and we can do an e-pole here, right? We can do an e-pole here by cutting like here and like here. and like here and here. See? This. We can do it like this. We can cut it here after dissolving that edge, and now we can do it like this. How is it done? What the fuck? Okay, now this is almost done. This here, enter, and this we can merge this, merge at last. Now this looks a little bit bad, but it's a 3-2-2 reduction using an end pole here, right? And the edge flow is preserved. Edge flow is preserved. We can apply subdivision surface here, subdivision surface modifier here. Let's do it here. Okay. Let's apply a subdivision surface of 2 here. Let's enable optimal display, let's disable optimal display. And you see that the edges flow pretty beautifully right here. We can try even to drag this here, try to make it a little bit more even, but you can see that this is good. This is good topology, right? Because it doesn't appear to show imperfections, right? We can even apply a matte cap with high gloss to see if this causes normals or anything to occur, but it doesn't, right? We can even like deform it, and it deforms pretty well. Let's do a deform like this. Okay, now this deformation, you see that the matte cap does show a little bit of deformation here, and this is why we try to avoid poles on the on deformities that we wanted to seem like flat places, right? So this is bad. Don't do that. But the topology is preserved. And this is what matters right now for us. Let's see my script. Where we at? Where we at? And this is a single end pole, right? To do this reduction. Let's now hide this, and I'll do once more add a plane. Let's enter edit mode, drag it a little bit down here, and let's copy it and drag it a little bit up here. I'll choose green for this one. Green. Now let's try again. This one I want to do not this. I wanted to do a 3-to-1 reduction, right? A 3-to-1 reduction can happen in many places, and it's a very simple one. This one It's very much simpler than the last one, and it can be done just like this. It can be done with, instead of one end pole, it can be done with two end poles, right? So we'll have the end poles around here, right? So we can extrude this. If we extrude this, we have the beginning of what we want. We have this here. Like, let's extrude, let's select those two and join them like this. And again, let's extrude this one up and let's join them like this. This one can be joined like this. And it is done. This is very easy. This is very symmetrical and is very like graceful, right? This is very good, very good. And it uses two e-poles, one here and one here. Those are the two end poles, right? Let's try again subdividing this. Control 2 or 4 maybe, and there we have it. Let's deactivate optimal display and activate the wireframe, and there we have it. There we have it. The detail is kind of clumped right here, and this is the effect of poles, right? Poles tend to clump the detail. E-poles tend to clump the details. And you see right here that end poles don't. End poles actually don't clump detail because they don't converge the detail, right? So let's just delete these edge loops with X and dissolve edges. And once we tab out, we'll see that the detail around the e-pole is it's less dense than around it, right? So this is an effect of the end pole, the e-pole. The e-pole doesn't clump the detail, but as we saw on this, oh my gosh. As we saw on this one, the e-poles tend to clump the details, tend to have higher density of details around the e-poles, right? This concludes what I have to talk. What I had to talk. This concludes what I had to talk about reductions. And now, with all we learned from this video, let's try to turn that cylinder from the beginning of the video into a better model with better topology that works better under subsurface subsurface modifier applications, right? So let's bring up the cylinder again. Bring up the cylinder again. I'll activate the wireframe for this one again. And again, if we try to apply the subsurface modifier here with control 2 or 3, we get this kind of onion-like shape with pretty bad look, right? So let's hide this for now. Let's turn off the matte cap also. I'll I'll turn I'm sorry, what's happening? Viewport shading just exploded here. Why isn't it showing what it used to? Like this. Like let's add a material. Red. It isn't showing, right? Okay. Okay, I don't know what happened, but I don't like how this is looking already. I think it's because it's shade smooth, right? I don't know why is this happening, but let's forget about it. Like, okay, we have a pretty bad model of a cylinder here, which is the default, by the way. Nothing that I can do about that. I mean, shiny. It's a little bit shiny and it's bothering me. Let's look, just turn up the roughness and I don't know, specular. Okay, forget about it. Just a little bit too shiny for my liking. And this doesn't have color. What the fuck? Maybe something that I clicked here. It's flat. Ah, okay. Okay. Shade auto smooth. This is a feature that has been introduced in the latest Blender versions, and it's just like it isn't. It is this thing, cavity. Um, I don't know what's happening here. Okay, let's work with this. I don't like it very much. Let's turn a little bit down this. Okay. I don't care. Now let's see. We can actually do, to fix this geometry right here, we can actually do an inset, and this will bring quads all over the place. Let's do it again. An inset, and all of those are quads. We can now delete this face, and this is a great edge loop. This works very fine. And we have a tool called bridge edge loops. Sorry, bridge something. Bridge. Grid fill. And we have this thing called grid fill, and we can apply this grid fill, and it works a little bit better for the geometry, right? This isn't 100%. I'll tell you why right now, because it doesn't have edge flow, right? It doesn't have edge flow. So let's not do that, and let's keep this, right? And let's just join each pair of those, right? Okay, so we can select each pair of vertices and we can join them. This is a little bit time consuming, I'm not gonna lie. And as you know, as you see it right here, it will create a geometry of triangles, which is not desirable. So let's not do that. What else can we do? We can actually do reductions, right? We can do reductions until we have a thing that we like. But reductions will cause a little bit of shading badness, right? So the other thing that we can do is do this. There's a very helpful thing for this one, which is the selection, select, and do checker deselect. This will select one, we'll select one and deselect one, select one, deselect the next one. And then we can do an extrusion, scale 0. And these, my friends, these are now not quads. These are now not quads. And then we can just merge those all at center. And now we have this pretty big face here. Just delete it and select everything around this and face. Oh. Face. Oh. Face. Fill. Fill. Oh, we don't have. Oh my god. Can we do like individual origins and fill? Oh. We'll have to do like this. One by one. And just mirror it. Definitely not the fastest way of doing it. And I'll do up here and just mirror it down there. But it is done, my friends. And now those middle faces that look like triangles are actually quads, and this has edge flow, right? It flows a little bit weird like this, but it has edge flow. It flows weirdly strange right there, right? But you can do edge flow here. You have perfect edges for edge flow. Now let's just do a mirror modifier here. Add modifier, add mirror, and we'll mirror it on the Z direction. And we'll bisect also on the Z. Okay. Bisect also on the Z direction and enable clipping and apply. Now let's see how does this behave under the subsurface modifier, right? Oh, look at that. Look at that. It's very much better. It's not 100% yet, but it's a little bit better, right? It has a little bit of shading issues here because the edge flow isn't 100% yet, right? We can see right here that it isn't 100% yet. What we're going to do here. We can try to reduce these kind of things. Let's see. Let's just select this. Let's delete faces. No. Faces. We can try to reduce this by selecting these edges and like shrinking them. Question mark. Now let's try reductions. Good, right? Reductions. Let's try reducing these three to 1, right? So let's just do this and dissolve edges. Nope. Dissolve edges. Oh, it isn't divided. It isn't divisible by 3. So I fucked up. We have to do a 4. Ah, fuck this. I don't want to do it. Sorry, I don't want to do it. I just don't want to. This is better, right? A little bit better. It isn't 100% as well. Just save. And let's do it other day, right? There's no one here right now, so I'll just end the stream. Goodbye.